Today, we're in Fairmont, West Virginia, at the Resolute Forest Products Fairmont Pulp Mill. The mill is known for manufacturing pulp from recycled paper, a process that takes waste and turns it into a usable product. Cass Berry is now arriving at the facility. Even though her father has worked here for more than 20 years, today is her first time visiting the mill. We will be joining Cass and her guide Anthony on a tour.
Good morning.
Good morning.
I'm Anthony. It's nice to meet you.
Nice to meet you. I'm Cass.
I understand you're here to learn more about our recycle facility today.
Yes.
So before we go in, I'm going to give you some PPE that we'll wear throughout the mill.
Okay.
We'll have safety glasses, vest, hard hat, and gloves we'll wear all the time. The earplugs, I'll tell you where we can have them in and not have them throughout the mill.
Okay.
Okay?
Sounds good. Thank you.
You're welcome.
Now that we've got our safety gear on, it's time to get started. The tour starts with the warehouse. Look at all those bales of paper.
So this is our lower warehouse, and we have the 3 dock doors, and we also have a roll pit on the backside, so we'll bring the waste paper in on rail cars and also on trucks, and we'll unload it down here. As you can see, there's a wide variety of what we bring in as waste paper.
Yeah.
We're starting to get a lot more shredded material, which makes it a little harder for us to grade, be able to tell what contaminants are there. But you can see we also get a fair amount of the printer's waste as well, which is a pre-consumer material, where this is a post-consumer material. So this has actually made it to the consumer, and we've brought it in after they've used it, and we're going to recycle it into our finished product. So from here, we're going to head upstairs, and I'll show you where it's actually fed in.
Okay.
Operators at the Fairmont Pulp Mill work in shifts around the clock to keep the mill running. Up to 1,200 tons of waste paper can be fed into the system in a single day. That is around 60 tractor-trailer loads of paper every day.
So you can see we got a lot more paper up here in the upper warehouse. How much do you think one of these bales weigh?
I have no idea how much.
So a lot of these, when they're compressed the way they are, they're going to be well over 1,000 pounds.
Wow.
You definitely don't want them falling over on you.
Yeah, definitely not.
This is one of our wire wolves. So what the wire wolf does, it'll actually cut the wires, and then it'll wrap the wires up into a wire ball, and then it feeds the paper in and puts the wire ball into a bin off to the side so the wire doesn't get into our system. They'll set the bells on so the wires are facing that way, and then there's an arm at the top that'll come down and actually cut the wires. As the clamp truck operator's coming up, they also have this trend lined up here that they're able to watch. That's our first stage brightness. So they have a certain recipe of bells that they're going to be feeding in, and they're going to be watching that brightness to make sure that they're staying in the right range. Because if their brightness gets too high or if it gets too low, then they might have to adjust that recipe a little bit to make sure that they get their brightness in the right spot.
What do you mean by brightness?
So the brightness is going to be how actually bright the paper is.
Okay.
As we send it to different customers, the customers are going to have a brightness spec anywhere from, we do anything from like a 78 brightness all the way up to a printing and writing grade, which is what we're on right now.
Okay.
That can be upwards of a 88 brightness, almost the brightness of printing and writing paper.
Okay.
You have any other questions? So this is our wet strength polypulper area here. We're one of the few mills, recycle mills, that'll actually take wet strength and use wet strength paper.
Okay. What is wet strength?
So wet strength is actually probably the best way to describe it would be the difference between toilet paper and paper towel.
Okay.
Toilet paper breaks down real easy when it's wet. A paper towel doesn't. It's actually made to absorb water.
Absorb it, okay.
So paper towels have a chemical put in them to help hold the paper together and make it have wet strength. A lot of the paper that we have here will actually have that chemical in it, and we'll add caustic into our pulper along with energy to be able to break that fiber down and be able to reuse it. So we're one of the few mills, recycle mills, that can actually handle this type of material.
Okay.
So we'll head down to our drum area now.
Sure.
So before we get down to the drum pulper, we'll stop here real quick. This
Okay.
is actually the feed that goes into the drum pulper. So where we were at the wire wolf over there, it'll feed up from that side, and then this can also feed the loose paper from this side. And as you look around at the waste paper, you'll see that we don't have a whole lot of newspaper or cardboard. That's for our bleaching process. So if you've noticed, if you leave a newspaper out in the sun, how it'll discolor, that's actually the lignin, which is part of the tree that's left over in the paper.
Okay.
So we actually have to watch. We do a kappa test that'll actually tell us how much lignin's in there, because it'll consume our bleach. So that way we can kind of keep a steady process in our bleaching.
Okay.
So we will head down to the drum now. So this is our fiber flow drum. The paper will actually be fed in this side with just water, and it's like a big wash machine. It just keeps tumbling it over and over until it gets down to this section where the paper is starting to break up. So after it's done pulping, it'll go to the screening section, and the fiber will actually go through the screening section, and the rejects come out the end of the drum. So you can see where the plastics, pop cans, bottles, that type of stuff will come out the end of the drum.
Yeah.
And then you can see on the platform there's a wire ball there too. So if we don't get all the wires out upstairs like we were talking about, they'll get in a big mess in the drum and come out the end of the drum in a big wire ball.
Okay.
So this is where the pulping process actually starts, breaking down the fiber. From here we'll follow it into the rest of the process. So as it comes from the pulping process into our system, we'll go through a set of cleaners. Right here, you'll see the high D cleaners. So they're actually going to take out the heavies, like the staples, paper clips, that type of stuff, some rubber bands. Behind you, this set of cleaners is called forward cleaners. So it's going to work on the same centrifugal force concept as the high D cleaners, but it's going to focus on a little different density. So it's going to take out more like sand and grit type of material, something closer to the weight density of the fiber, but there's enough separation there that it's able to get all that out. So you can see in here, this is what comes from our high D cleaner rejects.
Okay.
You see the staples, looks like there might have been a piece of a mirror even, the ring from a 3-ring binder, even pieces of rubber band. So that's going to be the high D cleaners is what's going to take out the biggest part of the contaminants, the heavy stuff, as it's coming through the system.
Now that the larger contaminants have been removed, it's time to focus on removal of smaller contaminants, such as dirt and stickies. Before they can be removed, these materials are broken down through multiple stages of thickening and dispersion.
So this is our press floor. So we have 2 stages of presses up here. The first stage is at the end, so after it goes through the cleaners and the screens, and we get all the big contaminants out, it comes into the press. The press is just taking the consistency up, getting the water out, so it can go into the first stage of dispersion. Dispersion is going to take and press the fiber against the fiber and break down the ink dirt and what we call stickies. Stickies is the glue residue that will be left over after it goes through the screening process. And so we're just trying to make those as small as possible. And that'll go into our flotation cell, which we'll show you here in a little bit. The second stage is after it's went through that process, and we're actually going to go through a second dispersion unit, which is called a crema. It's a 3,000 horsepower unit. It's going to go through that unit, and that's also where we're going to end up right after that, adding our first stage of bleach, which is a peroxide bleaching stage. So we'll head back towards the flotation cells now. So as we walk through here, you'll see that we have float cells. And these float cells are after each set of dispersion. So this is our first stage float cells back here, and this is our second stage. The way it works is we add a bunch of water to it, we thin it out, and then it'll actually cause foam in these float cells, and the foam will raise the dirt particles, the stickies, which is the glue residue that's left, and ash to the top, and it'll reject. So that's your first stage. This is the second stage, and then over here, this is a fiber recovery float cell that I can actually show you how it works.
Air is injected to the thin pulp slurry to raise the gray ashy material to the top, which is what you see here. The good fiber stays in the solution below. Next, we'll follow this ashy material outside just after it gets mixed with other process waste into a byproduct called short paper fibers.
So, what is that smell that I'm smelling?
So what you're probably smelling is a H2S odor.
Okay.
It's as the short paper fiber, which that's what this is. This is the rejects coming out of the system that we have to get rid of. So the little microorganisms that are in it are actually digesting it, and that's the smell that they give off as they're consuming some of it.
Gotcha.
And then on this left side is the plastics rejects. So this is what's coming from the drum and also from the core screen. So all the plastics that we get right now we're collecting and storing here.
Most of the material rejected from the fiber recovery process is useful. For example, short paper fibers are used as filler to reclaim mine sites. Regardless of the destination, the material is scooped up by a loader operator and placed in trucks to be taken off-site. Quality control is an important part of any product manufacturing. For a great visual demonstration of what gets accomplished at the mill, let's head to the lab.
Okay, so this is our main lab. We actually have 2 lab testers that work in here all the time. The one will be on that side. They'll be testing the process every 2 hours. So a lot of the things that we already looked at out in the mill, they'll be actually testing it all the way through. On this side, this is our finished product side. They test every hour over here, and we actually sell off of what their testing shows. So they'll look for everything from the brightness that we talked about earlier to stickies, which is they use the microscope to actually look to see how many stickies or glue residues left over. And then we have a dirt scanner that'll actually look at the hand sheet that we make, which this is for our hand sheets. And so, and actually we have some hand sheets here with us. This is the hand sheet from the fiber flow.
Okay.
So that's after we've taken out the big plastics and all that. But prior to the screening and cleaning, this is after the screens and the cleaners.
Okay.
And then this is our peroxide tire discharge. So this is where we've started to go through the press and the dispersion unit so that it's taking out the little stuff and we're floating it out. And then this is after the cream of dispersion and then floating it out again. And then we also do our second stage of bleaching there. And then this is what our final product looks like. So
Wow.
pretty big difference between what we start and end with. Do you have any questions before we move on to the DCS?
No.
Okay.
The control room, which houses the DCS, is the hub of the mill. The DCS allows for one operator to control most of the mill.
We always have one operator in here, and they're going to be watching everything from the beginning to the end. As you can see on some of the cameras, you might recognize the feed system up there.
Oh yeah.
And then on camera 3, do you recognize that area?
Yeah, but I don't remember what it's called.
Okay, well that's the reject end of the fiber flow drum.
Okay, yeah.
So on the left, you'll see where that
where
wire
the wire
ball was.
ball comes out.
Yep.
Yeah.
So he'll be watching everything from beginning to end, like I said, and he's got alarms that, if the level goes too high on a tank or if we start to have a screen plug or something like that, he'll get an alarm letting him know what's going on. And then we also have the effluent system down over the river, and actually have a camera of the river itself. Mm-hmm. So he's keeping an eye on that as well. So he's watching everything from a safety, quality, and environmental standpoint in here. And then also from a production standpoint, you'll see where the sheet's going into the dryer, and over here the sheet's coming out of the dryer.
Oh, okay.
And that's actually where we'll be headed next. We'll be headed down by the dryer.
Awesome.
So this is our double wire press. So once we have the pulp cleaned and brightened up, it comes into here. It's about a little less than 3% consistency. So it's 97% water, about 3% pulp. As it comes through, the double wire press will actually, the main job of it is taking water out. So it's going to start forming that sheet. As it forms the sheet, it's going to transfer it to the heavy duty press. The heavy duty press is actually going to take out more water. That's its main function. So by the time we get from the head box of the double wire press to actually going into the dryer, which we'll go down and take a look at in a minute, we're going from that just under 3% consistency to about a 45% consistency.
Wow, okay.
So if you look up, it's actually the sheets it's getting ready to feed into the dryer. And as I was telling you back there, the consistency is about a little over 45% or so. So about half of what you see above you right now is actually water feeding into the dryer. When it gets out the other side of the dryer, it's going to be about 10% water, 90% pulp roughly.
Wow, okay. Is the heat from the dryers?
Yeah, so we have to use a fair amount of heat. It takes roughly 20 minutes or so to get through, depending on what speed we're running, to be able to get the consistency down to that 10% water, 90% pulp.
Like a steam room here.
Yeah.
Drying the pulp allows the mill's customers flexibility for production. Dry pulp can be shipped anywhere and stored indefinitely.
So here's where the sheet finally comes out of the dryer. Do you remember what consistency I told you it came out at?
About 10%.
Yeah, so somewhere roughly between 10 and 14% water as it's coming out. So as it comes this way, this is a pulper. So if we have a problem here, if we have a sheet break, the sheet will go into the pulper, and its main job is just pulping that dry sheet back up, making it wet again.
Okay.
As it comes this way, you'll see the knives where it cuts it into 6 bells, and then we'll follow it out to the cutter lay boy. And then that sound you hear is where it's cutting the sheet the whole way across. And then the sheet's going to feed this way, and it's going to stack up on the elevator to a certain weight, and then those forks back there are going to come in and come underneath the sheets coming out, and then that elevator will drop down, and then the elevator will run the bells that way, and we'll follow that through the process.
All right.
Now that the pulp is clean, bleached, and dried, it's time to follow these pulp sheets to the packaging area, where the bales are prepared to be shipped all over the world.
So now we get to where we actually do the finishing part of the bells. So the bells will come out to this turntable, and it'll spin them and turn them this way to come down to the bell press. Or if we're in wrapper mode, the wrappers will actually go out that way, and we make all of our own wrap, and you'll see it, the wraps back there. So they're cut to a bigger size, so they'll be wrapped around the bell.
About how much does something like that weigh
So
now?
each bell is about 600 pounds.
Wow. So starting from the beginning of about 1,000 till...
Yeah, 1,000 plus for the furnished bells when they're coming in. And of course, we're removing a lot out of it.
Yep.
But then our finished bells are right around 600 pounds a piece.
Wow.
So as we walk down through here, you'll see how it picks up the bottom wrapper.
Yeah.
And then you'll hear a puff of air as it feeds through, and that's actually the glue feeding onto it. So once it gets the glue on it, it'll continue this way, and that bottom wrapper is going to fall onto the top wrapper. And then what this is doing right now is it's pushing and holding that glue until it's all glued together.
Okay.
And then it comes on down this way, and this is actually going to pick it up and spin it and wrap it like a Christmas present.
Wow.
So it's going to fold it in, fold it down, and then before it moves on, you'll hear that puff right there.
Yeah.
That's the glue spraying up underneath the wrapper. So now you've had glue sprayed the whole way around.
Wow.
And then it's going to press and hold again. And as it comes this way, that is a printer head over there. So that's going to actually come in and give it an ID number.
Okay.
And tell it what number in that lot it is. And right now we're making lots that are 250 bells per lot. And that's what'll fit in a rail car.
Wow.
So once it comes off the line, we'll stage it like this. This is a whole lot. This is 250 bells, so just over 70 tons.
Wow.
And that's how much we can fit in a rail car for shipping to customers that take a rail car.
So, in what ways will I see like this product again?
There's a couple ways you might see it. So you could actually see, we do a tissue grade.
Okay.
So that'll go out to customers that are making like a toilet paper.
Okay.
And then there's also a printing and writing grade that we do that'll go out to customers that are actually making printer paper.
Oh, okay.
So that pretty much concludes our tour for today.
Thank you so much for having me.
Sure. I hope you were able to see just how much it takes to take a recycled paper and turn it into a usable product.
It's been great seeing how it all works.
The process of manufacturing pulp from recyclable paper products helps the environment, preventing more than 200,000 tons of paper from going to the landfill each year.